We're going to begin section 5.2. We're going to talk about the vertical asymptotes. That's as far as we're going to get in this lesson. Vertical asymptotes, remember, asymptotes define the behavior of our graph. So when we have to graph these rational functions, that's where we're going to start. Notice these 5 examples. The format of these rational functions is different than the 2 basic functions. Okay, rational functions get complicated quickly, and it's nice to have the basic functions, but I also need to know what to do when they get a little more complicated like this. So our first step in graphing is going to be to find the vertical asymptotes. Where am I going to draw those dotted lines that the graph never, ever, ever crosses? Well, we kind of alluded to it in the last section. The vertical asymptote always happens when the denominator is 0. That's where I have a problem with my domain. That's where I'm going to have a vertical asymptote. So I'm going to do 1 or 2 of these. You're going to do the other ones, and then we will be done with this lesson. So the first example underneath that heading of finding the vertical asymptotes, I've got this function right here. Let's pretend we were asked to graph it, which we will when we come back next time. It's x minus 1 in the top, x plus 4 in the bottom. My first thing is I want to know, what is the vertical asymptote? What is that dotted line it won't go through? Well, it happens when the denominator is 0. So all you do every time on this is you take the denominator, whatever it is. This is x plus 4. And I'm going to say, when is that equal to 0? Okay, that is the problem. I cannot have a denominator of 0 in a fraction, ever. So what value makes that happen? Yep, x equals negative 4. If you subtract 4 from both sides, there's your vertical asymptote. So the first step, when we come back next time and we graph that very function, the very first thing we're going to do is we're going to draw a dotted line at x equal negative 4, because that tells us something about the graph right away. Okay, it tells us domain, and it tells us that the graph, when it gets close to that vertical asymptote, is going to do the crazy get closer thing. Okay, it never goes through a vertical asymptote. That's the thing to remember. So please do me this favor for the next one right here, x plus 2 over x minus 3. I'll give you 19 seconds to please figure out what the vertical asymptote of that one is. Okay, so this one, again, you just take the denominator, whatever it is, it doesn't matter. The x minus 3, I'm going to set it equal to 0. And so what value makes that 0? X equals 3. Perfect. Now, these are equations of the asymptotes. You don't have to put it in squigglies. We're not coming up with a solution set here. That's what we want. The line x equals 3, that dotted line is going to be my asymptote. The only other thing that you're going to be asked in this section is, in addition to linear denominators, you have quadratics. Got to kind of use our prior knowledge. So I'm just going to review this one. This one, I'm going to take x squared minus x minus 6 equals 0. Remember, the quadratic formula will always work every time, every day. But this one factors, so I'm going to go ahead and factor it. If you don't like factoring, go ahead and use the quadratic formula. The 2 factors of negative 6 that add up to negative 1 are negative 3 plus 2. No one took me up on this offer before the test, but if anyone needs some review on factoring, I have some videos from my intermediate algebra class I can throw your way and help get you up to speed. So we are going to have 2 values, x equal to 3, x equals negative 2. There are 2 vertical asymptotes of that graph, so lots of fun going on there. So your second to last problem for the day is find the vertical asymptotes of the next problem, 3x squared over x squared minus 16. Going to take the denominator, x squared minus 16, set it equal to 0. You actually have 3 options to solve this one. You can use the quadratic formula with a is 1, b is 0, c is negative 16. You could bring the 16 over, take the square root of both sides. That would be not too bad to do. I'm going to factor because it's a difference of squares. X squared is x and x, and then I've got plus 4 and minus 4. And that tells me that I, again, have 2 vertical asymptotes, one at negative 4 and one at positive 4. Last one, right next to it, one more quadratic. Find out what the 2 vertical asymptotes of that last problem are, please. All right, so I've got x squared minus 5x minus 24. I want that to be equal 0 because I got to know when am I going to have a problem with this denominator. And so again, quadratic formula will work great for you, but I made this to factor because I'm not interested in torturing you with decimal vertical asymptotes or anything like that. So my x and my x, my 2 factors of negative 24 that add up to negative 5 are negative 8 and plus 3. And so we get x is equal to 8, x is equal to negative 3. Those are the 2 vertical asymptotes of that graph. So you can practice that as part of your homework. That's as far as we will get today into section 5.2.